Welcome aboard, everybody. Let's see what we got over here. How's everyone doing today? There we go. Got a little green tornado going, don't we? It's kind of nice. How you doing, Very Cools? Welcome aboard, everybody. Let me give a good drop of sodium hydroxide here on this flask on the right. Up. Got a little plug in my bottle here. Isn't that cool the way that green material just kind of stays focused in the center there? Just add a little drop of sodium hydroxide. Like violet goes right through. Hey there, red sky. No, I don't have any potassium hydroxide. No potassium hydroxide. Let's add some hydrochloric acid. I've got some quite a few different experiments ready for us today. We're just going to start off just by observing some beautiful color changes here. And then I think we'll switch over. Let's do some like separation experiments next. It's kind of nice. I'm doing all right, Red. That's cool, man. We got something weird going on over here on this side. Nice, nice, nice. Let's get some colors going, baby. Hope everyone's doing okay. Oh, we got a little flash of the rainbow. Come on, man. Let's see if we can get that a little better. Let's add some hydrochloric acid over here. Same acid's found in your stomach. We're going to do that over there on the left. I'm also going to do it over here on the right. It's going to lower the pH, cause the color shift to a red. Doing all right there. Here we go. All right, let's add like, I don't know, 2 drops of sodium hydroxide. There's 2 over there, 2 over here. See what we get. Got a little rainbow action going over there on the right. It's beautiful. Nothing on the left. Let's give it another drop of sodium hydroxide, see if we can't pull it off. There we go. Oh, a little too much sodium hydroxide. Little too much. Let's acidify them both again, adding some hydrochloric acid to both sides. That'll shift us to a red color. Oh man, we got a nice little rainbow on the left there. That was pretty. Nice flash of the rainbow. Okay, let's do 2 drops. Sodium hydroxide on the left, 2 drops sodium hydroxide on the right. See what happens. Again, we got that rainbow flashing over there on the right. Looks like maybe a little too much base on the left. Let's try her again. We'll acidify it by adding hydrochloric acid. You guys want to do some separation experiments? What do you think? What do you think? 1. Let's do 1 drop of base over there on the left. Come on, baby. Give me the rainbow. Oh, let's see. If gold is 79, what's it? Platinum, gold, iridium, platinum. So it's going to be 77, I'm guessing. Here we go. 1, 2. Hydrochloric acid on the left. Hydrochloric acid on the right. A little more. Let's go. 1, 2 drops. 1, 2 drops. Give me some rainbow, baby. Yep, I'm consistently getting the rainbow on the right. Left, I'm having a little trouble. How's everyone doing out there today? Hope we're doing good. Hope we're all doing good. How you doing there, Kylie? Welcome aboard. I think we're gonna let's shift over. Let me just try it one more time. Hello there, Pink TM. Welcome aboard. It's great to hear there, Kylie. Very nice, very cools. There we go. All right, now. Hello, Pink TM. 1, 2 drops. 1, 2 drops. Uh-oh, I had a little trouble here. Boy, that's pretty. Hey, let's go over here. Let's see if we can set this up over here, just for the heck of it. Come on, let's try this. Let's try this. Do something different tonight. Okay. Let's see how this works out. I'm going to take this bottle here. All right. I wonder if I should use a white background. Maybe if I just move it up here, it'll work. Okay, here we go. I'm going to take this white, this clear and colorless bottle. Here, let me get a white background. I think it'll look better. I think this will look better. It's going to be brighter for sure. There we go. That's going to look better than the black. I have the black for the fluorescence experiments if we end up doing those. We decide on them. All right, now we can see the color contrast really well. All right, let's pour some fluid in here. We'll fill this bottle all the way up, shall we? All right. Where's my, here we go. All right, I'm going to fill this bottle up. In goes the liquid. Let's fill that thing all the way to the top. Or close to it. Nice. Now, if you look carefully, you might notice, let me move it forward a little bit. You might notice a little difference there. Kind of looks bubbly on the top and not quite so bubbly on the bottom, if you're looking carefully. Now what I'm going to do is I'm going to add some food coloring to this. What food color should I add? I could add some violet food color. If I wanted to. What other food colors do I have? Hey, it looks like I've got some red food color. I've also got some yellow food color. And I've got some blue food color. Which one should I add? Red, says Christian. You want to add some red? Well, Christian's quick on the draw, so we're going to add red. Mimi says blue. A lot of people are saying red. We got all sorts of different colors. Here they coming through. I'll tell you what. Since I got so many people wanting so many different colors, let's set up 3 different bottles, shall we? Let's just do 3 different bottles. We'll add different colors to each one, okay? We'll set up the same experiment in each bottle. And then we can add different colors to each one. Let's do that, okay? So here we go. So I can keep everybody happy. I got to fill these up, though. So let's fill this bottle up with the liquid. And we'll fill this bottle up about the same amount, eh? There we go. We'll fill this bottle up with the liquid. That's pretty good. All right. All right, folks. Now somebody wanted me to add some red, so we're going to add that to the first one. What is the liquid? That's a good question there, Pink TM. Here we go. On the first one, we're going to add, let's go 2 drops of red. In they go. 1. Oh, curses. I bought these brand new, so of course they're going to have that little safety seal, doggone it. So I'm going to have to get rid of that. So I can actually add this stuff. Come on. It's hard to do with a gloved hand. The question is, what is the liquid? We're gonna pause on the answer to that for a bit. You'd think I'd have this ready. You can take some guesses if you wish. Yeah, we're going to do purple. We're definitely going to do purple. We're going to do all the colors. Except I don't see a whole lot of people wanting yellow, so we're not going to do yellow. I haven't seen too many people asking for that. So let's see. I got the red ready. And what I'll do is I'll put this bottle front and center because, in my opinion, watching the liquid, or excuse me, the dye enter the fluid is kind of beautiful. Let me get this out of the way so it looks kind of nice. Here we go. In goes the drop of red. 1, 2. Come on, baby. Doesn't that look beautiful? Absolutely looks beautiful. Kind of like some fingers or tendrils dropping down into the fluid. Isn't that beautiful? I think it is. I think it just looks gorgeous. Look at those finger-like tendrils as they drop down into the fluid. Like a little explosion, huh? So that's the red. Kind of pretty. All right. Now we're going to add some blue. So let's get the blue one front and center. My fingers, of course, are all red and blue now. Let's move this one out of the way. Let's check out the blue food dye being added. What is the liquid? Well, I'll tell you what. There is some water in there. There is definitely some water. It does look a little bit like blood. Here we go. 2 drops of blue. 1, 2. Look at that gorgeous flow of fluid. Isn't that just pretty, the way it just kind of does that? I don't know. Look at that. There's just kind of these tendrils that kind of fall down into the fluid. It's very pretty. Nicole, we could probably do that. I'm gonna do it one at a time first. The nice thing about doing all the colors together is you can just, you can do that later. Very pretty. So we've got this one has the red food dye, of course. This one has the blue food dye. Of course, we can see those tendrils going there. The blue is the best, huh? All right, now we're gonna try the violet. So here's the one that's the purple color. Let's put a drop in and see what happens, all right? Here we go. It does look weird. Very weird. Here we go. 2 drops of violet. 1, 2. And there we got that same kind of odd tendril-like mixing effect that is just really beautiful. Very pretty. I love the way they just kind of almost look like a little explosion. Oh, Mariah, I don't want it looking like that. Okay, let's get them all mixed up now, all right? Let's get the red one mixed up. So I'll do that. I'll put that one front and center. We'll get the red one mixed up here. Mix her up, baby. And sure enough, you can see that there is one uniform liquid in the bottle. And the red dye, spreads out through the entire bottle. Let's see if the same thing happens with the violet. You think violet was the best, huh? Transition, or Nicole? It does look like a monster. Special effects. Oh, where's the lids? For crying out loud. Where are the lids? Here they are. All right. Let's get this one mixed up. And once again, we see that there is a uniform liquid with the violet color, the violet dye spread entirely throughout the fluid. And then we're going to do the blue one. Here's the blue one. Let's get this one mixed up. So what is that, asks Moises Martinez. What it is some food dyes, either red, violet, or blue, that have been well mixed into a certain liquid. Now, I haven't told you, how these dyes are made. They're just food dyes, really. This is just red food dye. This is violet food dye, purple food dye, and this is going to be your blue food dye. So here's the purple, here's the red, and here's the blue. Okay, now what we're going to do, I'm going to tell you what the liquid is there, Red Void, okay? We are definitely going to do that, okay? I will tell you. I'm going to explain the whole thing. But for now, what we want to do is I'm going to open this up. And now I'm going to add some table salt. So where's my table salt? Right here. So you can see here, I got this cup. I'm going to tell you, Nicole, here's the cup right here. All right, we're going to add. The liquid is water and something else. All right, the liquid is not just water. It was water to begin with. So these bottles here, if you've been following along, if you've been, since the beginning, this is just water. The stuff that I added, I'll tell you that, the stuff that I added after is isopropyl alcohol. So water and isopropyl alcohol, they mix in all proportions, which is why you get one uniform fluid in all three bottles. And the dye spreads out all the way through those, the uniform fluid. Now what we're going to do, though, is we're going to do something called salting out. And what I'm going to do is I'm going to add to this bottle here, I'm going to add some salt. And the salt, there we go, will dissolve into the fluid. But something interesting happens. You see, one of the liquids dissolves the salt much better than the other. And one of the liquids does not dissolve the salt well. In other words, the salt is going to dissolve in the water, so you're going to get salt water, and the water and the salt, they mix together so well with such a strong attraction that they push the alcohol out. So it's kind of like when two people meet each other and they have such a strong attraction for one another that they start to date exclusively or to see each other exclusively. The same thing, by analogy, is going on in this bottle. The salt and the water have such strong attraction for one another that they, so to speak, bind or mix exclusively. And the attraction between the water molecules and the salt ions is so strong that the alcohol molecules cannot overcome that attraction. And because the alcohol molecules can't overcome that attraction, it gets pushed out. Now, the alcohol is less dense than the salt water. Let's see if we got enough salt dissolved in. I don't know if I'm quite there yet. Oh, yeah, it's working. It's working. So the alcohol, let's just a little bit more. I think maybe I can just mix it up just a bit more. See if we can get it in there. Now, the alcohol is going to be less dense than the salt water, so the alcohol layer should rise to the top, and the salt water will be less dense, so that should go to the bottom. As long as we get it mixed together well enough. Do I have it? I might need a little more salt. I think I might need just a bit more salt. So we're going to try just a bit more. Well, that would suck if this doesn't work, wouldn't it? That would really stink. I did change the proportions just a tad. Let's just add a little more salt here. Get her going. See if that helps. Just a bit more salt might do the trick. Come on, baby. We got people watching. This thing's got to work. Here we go. Mix that thing up. Let's see if we can get the salt and the water to attract each other strongly enough, put enough in there that it'll force the alcohol layer out. Is it going to go or isn't it? Do I have a dud today? I think that tells me we're going to let that set for a bit. I'm going to try these other ones too. Well, curses! It's just barely there. I can just barely see it happening. Actually, I think it's working. It's just that I think the red dye is dissolving in both layers. I think that's what's going on. Here, let me see this with the blue, or excuse me, the violet. This will tell me whether I've got it working or not, all right? I think it's just that the red dye is uniformly dissolved in both the alcohol and the saltwater layer, which is why we're not seeing a difference there. That's what's going on. See, I've not done the red dye on it by itself before. That's the first time I've tried it. But this one I've done before, and I'm pretty sure I know what I'm going to see here. So I should have done this one first. All right. I've added the salt. The salt and the water should mix so well that they'll mix exclusively, and they should force the alcohol layer out. Yeah, that's what's going on. I can see there's 2 layers in this one over here. It's just that the red dye dissolves well in both layers. That's why. That's why I couldn't tell a difference over there. All right, let's try this one. This one will be able to see a difference. I've done this one before. So we've got the violet dye in with some salt water and some alcohol. The salt water is more dense than the alcohol, and so it should sink to the bottom. If I got enough of the salt dissolved in there, come on, baby. Get enough of the salt dissolved in there. Give it a shot and see. Come on. Let's see if it's going to separate. Is it going or not? Oh, boy. Bad day. Bad day for me. I've used a little more water than I normally do, which might be why I'm having an issue. Got to keep it separated. Oh, yeah. All right, let me try this. Curses! I think I use a little extra water than I'm used to, so I'm going to just take a little bit out. We're going to take a bit out. We're going to try the same thing. Let's see. How much? Need to get out about 20 grams. Oh, rats. All right, this might work. I hope it does. There we go. We'll try the same thing again. We're going to add some of the isopropyl alcohol here. This is odd, man. I don't know why I'm struggling today. Not a good day. All right, let's add some the alcohol. Get that in there. Come on, baby. Fill her up. We'll go about right there. Okay, so I've got the alcohol. I've got the water. We're going to add the few drops of my purple food dye. Yeah, I might need more salt. I may need. I've done the here. You can see this one is starting to. You can see this one. You can see a slight difference. You see how the bottom, you can see a different layer than the top. I just think I'd change the amount of water, and I think that's what's causing the issue. So we're going to try it here. I'll add a bunch of salt here. I also am using a different brand of salt, but that shouldn't matter. It really shouldn't. It's table salt, so it should work. Let's put this in there, get it all mixed up. See if the ratio of water that I use is what's causing my issue. I think it is. All right, let's shake this baby up. Could also be the temperature of the water. I don't know. I tended to use a little bit warmer water than usual, too. Come on, shake. Let's get this stuff dissolved. Get this dissolved. So once again, the way I prepared this particular bottle is I mixed together some alcohol, some isopropyl alcohol, 91%. I also mixed in some water. And then I put in some purple food dye. And then I added in 50 grams of table salt. And now I'm trying to shake to get as much of that salt dissolved as I can. And we're going to see what happens. Come on, baby. Come on, let's go. Yeah. See it down there at the bottom. I can see a slightly different color down there at the bottom. Let's get a little more mixing going. I might be able to get a bit more salt dissolved. See what happens. Yeah, now you can see it. You see it down there at the bottom? See that blue color growing in? And up there at the top, it's kind of pink. So this is, the separation is occurring here. What's happening is the salt water is attracting and it's pushing out the alcohol. There's an alcohol layer on top and there's going to be a salt water layer on bottom. I think if I can get more salt in there, we may get a better separation. But you can see there's a huge alcohol-rich layer on top where the red dye in the violet dye went. And then there's a saltwater-rich layer on the bottom into which the blue dye from the purple dye went. Allyl alcohol next. It worked okay. We got that one separated. I think this one probably has a bit too much water in it in order to do the separation. I'm going to pass on that one, but this one worked fairly well. This one worked fairly well. We can totally see the separation. I'm going to shake just a little bit more to see if I can get a little more of the salt dissolved. More salt that I can get in, the more separation we're going to get. Let's just see. All right, let's see what we get. See if we get a little better separation. I haven't added salt to the blue one yet. Are we separating? I think we are. You can see it now quite well. You can see, here, let me get these out of the way so you can see it. You can see up at the top, we have the alcohol layer. And in that alcohol layer, you can tell that the red or the pinkish dye in the violet food dye has been dissolved. Down here at the bottom, you got the saltwater layer. The blue dye and the purple food dye ends up in the saltwater layer. And in the mixture, there's an emulsion. That emulsion is a mixture of the alcohol layer and the saltwater layer. So the emulsion's a transient mixture of alcohol and saltwater. Those don't mix. Alcohol and saltwater don't mix, and so those are going to, that layer is going to separate. It's going to go into an alcohol layer on top and a saltwater layer on bottom. It's beautiful, isn't it? Thank you there, Mileno. Mateo, you guys want to try the blue one? I think I screwed up. I think I screwed up on the blue one because I did not add enough. I added actually too much water to this mixture. But I do have a third bottle we can try, all right? We'll do a third bottle here. I just need to get a little bit of water out of this. So give me a second here. I'm going to get a little bit of water out of this one. And we can try it then. All right, this will be close. This should work. So here we go. I've got some water in here. And now I'm going to add some isopropyl alcohol to it. Here we go. Let's get it going in there. Thank you there, Mileno. All right, in goes the isopropyl alcohol. So this is water. To the water, I'm going to add some isopropyl alcohol. This one we're going to leave the dye out, because there's an interesting effect that happens when you leave the dye out. So again, now I have a mixture of alcohol and water. We'll mix this up. Let's mix that up. You can see how the bubbles are kind of going through the alcohol layer. What is your favorite chemistry? Asked Forsaken Forever. Yes, they are, Emerald. These are ice sparkling water bottles. It is quite a bit pink. I saved these bottles for later. So here we go. Hello there, C. Sean. That's what we're going to do, Nicole. We're going to do it this time without adding food dye. So I've mixed up the alcohol and the water. in one fluid. Alcohol and water mix in all proportions, which is why this is now one homogeneous fluid. Hello there, Abdullah. Yeah, you can separate it. All I'd have to do is like draw this layer off with a pipette, and then the saltwater layer is going to be on the bottom. Okay, now we're going to add salt to this. Here we go. Let's add salt to this bottle. And we're going to get it all dissolved, and we're going to see what happens, okay? So, remember, when we add salt to a mixture of alcohol and water, the salt and the water preferentially mix. They like each other so much, so to speak, that they bind exclusively and push the alcohol out. So it's the same thing as when, the attraction between two people is so strong that they start to date exclusively or mix exclusively, so to speak. In this case, the alcohol and the the water and the salt mix together so strongly that they attract each other so strongly that they mix exclusively. And because the salt and the water mix together exclusively, they will push the alcohol out. Now, the alcohol goes to the top and the salt water goes to the bottom because alcohol is less dense than salt water. And so the more dense fluid, the more dense salt water sinks, and the less dense alcohol floats. Try to get this. How's it blue, Mateo? That it becomes blue by me adding dyes to it. Okay, let's see if this is enough salt dissolved to cause the separation. Let's give it a shot and just see. My day's good, Cool Bird. How about yours? Salt does dissolve in alcohol, just not really well. If it has a choice, so to speak, to dissolve in alcohol or salt water, it will choose to dissolve in water. Thank you there, Emiliano. Good to hear, Cool Bird. I think I'm seeing some separation. You can see there's a layer here. You can see there's a layer here where the salt water is, and then up above there's actually the emulsion. Boy, you can see the three layers. It's tough to see. I can see them. So there's a layer here. There's some junk in the salt that has sunk below not only the alcohol layer, but the emulsion. And that junk is resting on the layer of salt water. So the salt water layer is right about here. It's hard for me to tell the difference between the interface. I think the interface between the alcohol layer and the emulsion's like right here. So the emulsion's about this thick right now. And it's slowly getting smaller. What substance can you dissolve most into water? What a great question. Yeah, sugar. So, Kalura, there are some things that we say mix with water in all proportions. Alcohol, like ethyl alcohol and isopropyl alcohol, those are two things that will do that. They'll mix with water in all proportions. Sugar is another thing that dissolves well in water very well. MG, this phenomenon is called salting out, and it's a way that we chemists use to do separations. Oftentimes, we want to separate a compound out of a mixture, and one way that you can do that is through the phenomenon of salting out. Yeah, we'll do that here at the end here, Benteo. Thank you there, Sirius. Okay, so now that we know, I know I got two layers. I can see them, right? I can see sort of that. You can see right there, there's some undissolved material that's laying at the interface between the alcohol layer on top and the saltwater layer on bottom. So now that I know I've got two layers in this bottle, what kind of color should we add? So Hot Gas is asking, what is the difference between dissolving and emulsification? Let's show you this. We'll get back to this bottle layer. So in this bottle, what we would say is that the pink dye has dissolved in the alcohol layer, and the blue dye has dissolved in the saltwater layer. We'd also say the salt has dissolved in the water. If I shake this up, then I make an emulsion. An emulsion is transient. It's everything's mixed together at this point. So an emulsion is a mixture that's transient. And if it's transient, that means that all the components have not dissolved in one another. And what is happening in the emulsion, which is going to be here in the middle, the emulsion is going to be a mixture of the pink dye, the blue dye, the salt, and the water. Now, all four of those don't dissolve in each other. It is the case that the blue dye dissolves in the salt water, and so it separates out of the emulsion. And it is the case that the pink dye dissolves in the alcohol, so it moves with the alcohol. The emulsion is here in the middle. You can see the emulsion is like a violet color. The alcohol layer is pink. The saltwater layer is blue. And the emulsion is a transient mixture in which all four components, not dissolved in each other, will end up separating out. I hope that helps. Sirius Snape says they want to do green, huh? Let's do this. Let's do this in this bottle here. We're going to do this in this bottle. What I'm going to add to this bottle is some universal indicator. Universal indicator is a pH indicator. Yeah, hot gas, that can be why sauces separate. So anytime you cook with, say, oil-based sauces and water-based sauces, those two aren't going to mix real well, unless you add an emulsifier. An emulsifier is something that sort of allows things that don't dissolve in one another to mix for a long period of time. All right, let's add some, we're going to do this. I'm going to add some pH indicator to this bottle. This is going to be fun. So here we go. This way, I can get a bunch of different colors. All right? We'll show you what I mean here in a second. Okay. Here we go. In goes the universal indicator. Now, universal indicator is also known as rainbow indicator. It changes color depending upon pH. So long, cool bird. Thanks for joining us. So if you look, the universal indicator's got like a green color, which means it's neutral. When I add it to the bottle of water, it looks like, is that green color persisting? Or is it shifting to like a yellow-green? In my opinion, that's shifting to like a yellow-green color. And that's telling me that the alcohol-salt mixture is like a slightly acidic. It's just a little bit acidic. Because when we see a yellow color with our universal indicator, that tells us that the mixture is acidic. All right? Here, I'll get you the pH scale to show you what I mean. So here's the pH scale with the universal indicator that I'm using. If we see green, we see a green color. That tells us that the universal indicator is neutral. If we see yellow, it's really close to neutral, but it's just slightly acidic. And that is indeed what we're seeing, okay? So that yellow color tells me, aha, this is a slightly acidic solution. Let me mix this up. We'll give it a mix. And let's see which layer the universal indicator dissolves in. Now, this is a little complicated, just like this food dye has two different dyes in it. The universal indicator has different dyes in it as well. And it turns out that the universal indicator has 4 different dyes in it, all right? So it's a complex mixture. But what's interesting is, I don't know if you're noticing this, but it seems like most of the color is residing in the alcohol layer. There's just a little bit. There's just a little yellow tint, just a little yellow tint to the saltwater layer. So for the most part, the dyes in the universal indicator are ending up in the alcohol layer. It's a mixture, Ben Scott. So the pH indicator I'm using is made of 4 different compounds. They are methyl red, bromothymol blue, thymol blue, and phenolphthalein. So those are 4 different molecules that together give you the color or colors that you're going to see. So that's what it's made of, Vissy, those 4 different... That's right, the green turned yellow because the pH in the bottle is slightly higher than, slightly lower than pH 7, so slightly acidic. Now what I'm going to do is I'm going to either add acid or base to this bottle. And that'll change the acidity or basicity, which is the opposite of an acid, of of the contents of the bottle. So I'm either going to add hydrochloric acid, which is the same acid that's found in your stomach. It's just that this stuff is a lot more concentrated. And when I add hydrochloric acid, it'll acidify the contents and lower the pH. Let's do that. Let's just add a little bit of hydrochloric acid here. Here we go. Let's just try it here. I'll add like 2 drops. 1, 2. So you can see where I added it, where I added the hydrochloric acid, you can see like a red color developing. And that should make sense. No, you don't want to drink this, Nicole. That should make sense that we see a red color because indeed, or like an orange color, you know, as it gets more acidic, your pH is going to drop. So how does the pH indicator actually work? So the way a pH indicator works, it has molecules in them that will bind to protons. So acids, they donate these ions that we chemists call protons. So when there's an acid present, there's a lot of protons around. Protons are just H plus ions, all right? And when an indicator, so let me turn this light on so you can see what I'm doing here. So when, can you see that H plus? Yeah, okay, I see it. It's not the greatest lighting, but it's an H plus ion. So when an indicator molecule sees that H plus ion, it grabs onto it like that, and it makes a ring shape. And that structure imparts a certain color to the molecule. Now, when bases are present in the mixture, they take these protons away. They take it away. And when the protons get taken away from the indicator molecules, they go boop like that. They open up. Their structures change. And with that change in structure comes a change in color. And depending on how the various dyes act, the colors are going to be different, you know, depending upon how many protons are around in the various colors of the indicator. So here we go. That's cool there, Matthew. Let's shake this up and see what happens. Shake her up, and it looks like we have a shift to orange, which tells me that the pH has dropped in my flask from a pH of 6 down to probably like a pH of 5 or 4. And that makes sense because I added hydrochloric acid. Hydrochloric acid's an acid, so of course the pH has dropped. And the other thing I notice is that the dyes seem to dissolve better in the alcohol layer than the saltwater layer when that, you know, as the pH gets lower, less of the dyes dissolve in the water layer. Isn't that cool? And I can sort of see the 3 layers here. You got the saltwater layer, you got the alcohol layer here, and then in the middle, you can see that faint, it's not quite as orange as up here at the top. This is our emulsion. Sean Dukes, the indicator is not showing much in the saltwater layer because the indicator dyes do not dissolve well in the saltwater layer, and this is particularly true at lower pH. All right? Okay, Alvaro, you should add base now. This is for Alvaro. We're going to add some base now. When we add base, the pH is going to go up. All right? So let's see what happens here. So there'd be some kind of way to make a similar system for infrared and UV, like an indicator that wouldn't work with visible. Oh, yeah, we got all sorts of stuff. So there are molecules that interact with UV light. There are molecules. I can show you one today if you want. I can do an experiment with some UV light that's kind of cool. So, yeah, you have, you know, that's what's beautiful about chemistry. You got all sorts of different molecules. You got all sorts of different ways those molecules interact with light. It's fun. So you can, you know, you can play around and do a lot of different things. Okay, I'm going to add some sodium hydroxide base, which is going to increase the pH, all right? So here we go. Let's add 2 drops of sodium hydroxide base. Well, hold on a second. My stopper, my bottle has a plug in it. Let me just get this open. There we go. All right. That should work now. In goes 1 drop. In goes another drop. So 2 drops of base. Let's add a 3rd drop, shall we? And I'm going to add a 4th drop just for good measure. Okay. If you've got a careful eye, you might notice that there's been a little color shift there. But let's just shake it up and see what happens to the pH. It doesn't look like much happened, right? Thanks there, Sirius. Here we go. Come on, baby. Let's see if the base made this change color. Come on, let's see. What's going on, man? What's going on? Look at that. Come on, that's cool. It changed it to blue. Of course it changed it to blue, right? I added a bunch of base, and base will increase the pH. It's kind of cool. Oh my goodness, something crazy's going on too. I love it when this happens. This is a lot of fun. Thanks there, Water Squirrel. Thanks there, Alvaro. Purple rain base. Make it purple. So this is really cool. This is like the opposite of this one, isn't it? Right? In this one, we got like the blue at the top, the pink at the bottom. In the middle, we got the violet. What's going on now? Remember, I told you there are 4 different dyes in this system. And it turns out that 3 of the dyes dissolve really well in the alcohol layer at high pH, which we're at now, right? We're at like pH 9 or 10. Okay. And one of the dyes, it's called phenolphthalein. It's pink in a base. It actually dissolves better in the saltwater layer at high pH. Isn't that cool? Isn't that just cool? So what you did was open up those color molecules. Yes, that's exactly right. So they don't grab the protons. That's correct. Come on, hot gas. Hot gas is turning into a chemist right before our eyes. Sean Dukes, that could also be the case that the sodium hydroxide dissolves better in the water. Yes. When the orange, the salt had a pinkish tint in it. Indeed. Thank you there, M. Leno. Thank you there, M. Leno. Can I get green at the bottom? I can't. So I can only get pink at the bottom. It is only the case. Now, remember, there's 4 molecules in here, dye molecules. Phenolphthalein only turns pink at high pH, which we're at, because all this blue that we see. And it only dissolves in this layer at high pH. So it only turns pink at high pH and only dissolves in this layer at high pH. Here, let's add some acid here. Let's just add some acid. All right. So when I add acid, that should lower the pH, right? Should lower it. Let's add a couple drops. Hydrochloric acid, 1, 2, 3, 4, 5. Let's see what happens. Let's see what's going to... Oh, yeah, there it is. You can totally tell I added it. You see it? You see how the acid has sunk down all the way to the interface between the alcohol layer and the saltwater layer. And as the acid has sunk down and collected here, of course, it has caused the pH to drop all the way to 3. So what we have here is an interesting effect where here the pH is 3. And up above where, you know, the acid just traveled through all this stuff. Here at the top, the pH is like 9 or 10. And because the pH scale works on powers of 10, let's see, the difference in acidity, let's see, the difference between a 9 and 3, that's 6. So that's 10 times 10, 6 times. So what's that? 10, 100, 1,000? 100,000, excuse me, 10,000, 100,000, a million. So what's really cool is the difference between this layer and this layer. There's a concentration of acid here that's 1,000,000 times higher than the concentration of acid that's up here, which is really interesting in a single fluid. And it's probably the same here. Like there's a huge difference in pH between those 2 layers. Thank you there, Mary Berries. Thank you there, Dapper. It is a crazy mixture. Gonna get 1 or 2. So, Mateo, we're not going to be able to tell if we're at pH 1 or 2 because it's red at pH 3 and below. So this could be pH 1 or 2 here. I just don't know. Yeah, Sean Dukes, it does get a little bit warm, but it's only like, if I remember correctly, it's like 57 kilojoules per mole, the reaction. And there's a lot of water in here that's able to absorb a lot of the energy of heat that's released in the reaction between the 2. So Doge Duo asked what would happen if you mixed it right now. This is for you, Doge. Let's find out. Come on, man, let's mix it up. I'm guessing there's a bunch of acid here, so the pH is going to drop. I'm guessing we're going to see like an orange or a red color, but I don't know. That's why we got to do the mix. And there we go. We shifted the pH. Uh-oh, what's going on, man? I'm seeing like yellow, but I'm also seeing some green. Where's it going to end up? I think it got neutral. It neutralized. I added the appropriate amount of acid and base so that they were equal. And when that happens, you get a neutral mixture. See how it's green? That was cool, man. We saw a shift down to yellow. But then as everything kind of mixed and equilibrated, we ended up at pH 7, which is neutral, which means the acid and base that are present in this bottle are equal. Although I don't know up at the top, that's looking kind of yellow-green. Come on, man, what's going on? It's like the emulsion is a green and the tops. I don't know what's happening here, folks. There is some goofy stuff going on that I can't 100%. I think I know what's happening. So there's probably got some solvatochromic effects going on. What's a solvatochromic effect? Well, solvato means solvent, chrome means color. And that means we're seeing that these dyes are taking on different colors depending upon whether they are just in alcohol or whether they are in the emulsion. Those are two different solvents. And in those two different solvents, they're going to have different colors. You got it, Hamesh. That's funny. Let me mix this up and see what we get. I wanna really mix this up. I do wonder if we had a solvatochromic effect there. I don't know. Maybe we did. Maybe we didn't. I don't know. Let's give it another mix and just see here. What would happen if I drank that? I guess the live would end in maybe 10, 15 minutes. I'd end up on the toilet. One of the dyes in here used to be the main ingredient in X-Lax. And isopropyl alcohol is known to, give you really bad intestinal problems if you drink it as well. So near the bottom, it's looking colorless. That's because, remember, the dyes do not dissolve well in the salt water layer. Only phenolphthalein dissolves down here at high pH. Hello there, Hup. Can I make it fizz? If I pump some CO2 in there, maybe. No, I won't drink it, Doge. Can I get it to 8? Asks Hamesh. Mateo, I'm an old dude, man. I'm like almost 60 years old. I'm a 60-year-old dude playing around with chemistry in his basement. It's true. All right, let's try to get to pH 8. I'm going to add 1 drop of sodium hydroxide because I'm going to increase the pH from 7, hopefully to 8. Doesn't batteries work like this with different ions? So the way batteries work is you're going to separate two materials. One of the materials likes electrons more than the other. And by separating those materials with a wire, you can get electrons to flow from the material that wants them less to the material that wants them more. And when you get electrons flowing through that wire, that's electricity. That's how batteries work. I think I got your pH 8 right there, baby. Come on now. Come on. There's your pH 8. Now, it's looking violet. To my eye, it's blue. Let me get this out of here. Maybe if I move, there's like a little, there you go. You can see it's a little more blue. I think there was a lighting effect that's going on. Yeah, I have another job related to chemistry, FGH. Oh, look. Oh, we got that separation again, right? We're at a high enough pH where the phenolphthalein has formed and it's dissolving in the saltwater layer. And we're like pH 8, so you can see like a greener color up here at the top. It's like a green-blue. I don't care. I'm old enough, Hamesh. I'm old. It doesn't bother me. So again, Nicole, different structures of molecules are going to behave differently. And so by changing the structure of the phenolphthalein, it actually gets a negative charge at high pH, and things with electric charges dissolve well in water. At lower pH, it does not have an electric charge, and so it remains in the alcohol layer. What is the mixture? Akis, what the mixture is, we have salt water, and we have alcohol. That's basically what we've got. I want to get some lighting so you can see this. This aqua color is really quite beautiful. I want you to see that. I want to see if I can get some lighting to help you see that. Let's see if this helps. I don't know if it's going to work or not, but we're going to try it. Oh, that one's dying. Let's see. I'm just going to try this. Oh. See, you can see that aqua color. That's the color that I'm seeing in the top layer. Of course, I see the pink in the bottom as well. Yeah, it's tough to... There we go. There's that aqua color. Pretty, huh? Very pretty. Can I get it yellow? Yeah, we can get it yellow. I got to just lower the pH, right? Yeah. So we're at a high pH. We're going to lower that pH by adding acid. Let's give it a shot. Let's give it a shot. All right, let's add some hydrochloric acid. So Odd Dogs Studios. You can actually go to my main channel page, and you can go to one of my long form videos. It's one of my, I don't do many long form. Most of my videos are short form. You can scroll through my long form videos and you'll see a bottle just like this on one of the thumbnails. And if you follow the directions there, you can see how to do this at home. I'm going to add 2 drops, maybe 3 drops of hydrochloric acid. Let's see. That's cool there, FGH. Yeah, so hot gas. Usually the acid in a battery is used as an electrolyte. So as the charges flow, as the electrons flow from the thing that doesn't want it to the thing that wants it more, that means negative charge is moving this way. And to counteract that, you need a negative charge moving in the opposite direction. And the electrolyte is usually what does that. It counterbalances the flow of charge, and that's often what the acid does. I forgot what pH you wanted. I think you said you wanted 6. I don't know if this is where this is going to end up. Hey, look at that. We got your yellow. Come on, man. Is it going to stay yellow? I don't know. We're going to find out. Let's see what happens. I think we got your pH 6, baby. Come on now. Yeah, I am, Nicole. Yes, Vissy. Something that would emulsify this mixture for a long time. Just for a really long time. All right, you guys ready for the face reveal? You want me to flip the camera around or you want to keep doing experiments? I don't care. What do you want? Deep purple. Sorry there, Hamesh. Lagging, huh? That sucks. Yes, I do, Mary Bears. Thank you there, Jill. I appreciate the subscription. A room tour? Yeah, we can do. You don't want to see the room tour, man. Oh, I mean, here's the setup over there for other experiments that I sometimes do. You can see some of my materials up there. You can see my stock over here. You can see the chemistry book that I wrote over there. You can find a link for that in the on my main channel page if you want to buy that. Let's flip this around, man. So how's everyone doing today? Well, I'm glad to hear that, Mary Bears. Hello there, Mohammed. Ah, Rob Smith, yeah? I'm just faking it. Come on, I'm just doing this for fun, right? Just doing it for fun. Thank you there, FGH. I appreciate that, Dia. I wish I felt 32. That's right, Vissy. I'm not going to break bad. Thank you there, Hamesh. Thank you there, Deuce 40. Hello there, Hero. That's good to hear, Hot Gas. A lot of clean living. Thanks there, Doge. No, I'm not Harvard educated there, Rob Smith. I got my PhD at the University of Michigan. They sometimes call that the Harvard of the Midwest. Yeah, we had a good time today, I think. I had a good time with you all. Thanks for joining in. Definitely thanks for joining in. Thank you there for subscribing there, Hamesh. Yeah. Thanks there, Rob. I'm glad you think it was good enough. Hey, yeah, consider subscribing to the channel. I know it's probably like backwards here. Let's flip it around. What the... Nicole says, I regret saying I want the face reveal. Can you go back to the science? You got it there, Heisenberg. Here we go. Yeah, there's your, if you want, subscribe. Appreciate that, Mateo. Oh, that'd be cool, FGH. Yep. Yeah, thanks for hanging out today. I had a good time. We did some experiments, had some fun, did some color separations. Let's do one more here. Let's do the one more here. We're gonna add a little bit of sodium hydroxide to this bottle. Give it one more shake. See if we can get the that nice color separation. Look at there. You can totally tell I added base, right? Because the pH is, the color is shifting to blue, which tells me the pH is going up. Thanks there, Doge, for the subscription. Let's give this a nice little shake. See what we get. Looks like we went straight to blue. And we're going to remember that one of the indicator dyes is going to end up in the saltwater layer. And so that's going to look pink. That's where the phenolphthalein ends up. And then the others are going to end up in the saltwater, the alcohol layer. So FGH, my PhD was focused on the very first step in photosynthesis. The very first chemical step in photosynthesis. There's a enzyme in plants known as photosystem 2, and they catalyze the oxidation of water. So water goes into the plant. It gets split into oxygen gas, which the plant releases as waste, fortunately for us, which is certainly not waste to us. And then the hydrogen atoms from the water get converted into protons, which protons and electrons, which the plant's able to convert through other enzymes into energy. That's cool, Doge. I wish you could see the lizard. Thanks, Air Hero. I appreciate it. You got it there, Vissy. All right, folks. I'm going to head out. I appreciate you hanging out with me this afternoon. I'm 57, Nicole. I appreciate you all hanging out with me. I had a good time. The stuff that plants, so there is some chlorophyll molecules involved in photosystem 2. There's quite a few attached. It's a huge enzyme. It's just like this huge molecule. And there's a bunch of chlorophyll molecules attached to it. So it back in the 1980s, Mateo, that's when I first had a chemistry class, way back in the 1980s. Saint, sorry you missed. We're going to see you next time. Thanks, Vissy, for hanging out. Glad you liked the experiment. We're going to see you next week, right around this time, all right? Glad to hang out with you all, doing some color separations. We had a good time. We'll see you next week. Enjoy the universe, folks. It's got beauty all over the place. Pay attention. Take a little time. Check it out, and maybe spend some time learning. I usually go live around this time, Doge. So long, folks.